Yeah, so I'm here to present some of my some very preliminary results that I found with colleagues at CNRS in France whilst working at Work Package 5. So a little bit of a background. We already heard that in Antje's talk. A very popular region to examine the added value of initialization for decadal prediction skill in is the North Atlantic Subpolar Gyre, because that is a region where we found a lot of added value through initialization for prediction skill of surface temperatures in CMIP5. Now this is just an example. The plots that you can see on the left-hand side, it's the initialized hindcasts at lead year 5 to 7. In the middle, it's the historical simulation, and then at the right, there's a difference plot. All of this is taken from the IPSL model and the CMIP5 version. And skill is quantified as correlation against head ISST. So you can see that one of the regions that stands out in terms of skill improvement through initialization is the North Atlantic Subpolar Gyre, which in the right-hand plot you can see marked with a black box. And yeah, we keep operating under the assumption that this is the case, and a lot of people have shown this. Now, the reasons for this are debated. Some people suspect it's AMOC, some people suspect it's probably volcanic eruptions. But most of the literature actually that's out so far suggests that the high skill in the subpolar gyre is due to internal variability of the climate system. Another reason why people look at the subpolar gyre is because this region has been shown to be quite impactful for example, extreme summer temperature over Europe. That's a paper that I published together with colleagues last year, but also for Sahel rainfall, for example. Now, what I did is I tried to replicate these results using the CMIP6 model system, and you can see here essentially the same plots as before, but differently put. So in the top, in the sort of the left-hand plot is initialized predictions. Now the top right-hand side is historical simulations, and at the bottom right you can see the difference between the two. The difference between this plot and the one that we saw before is that this is a multi-model ensemble mean, where all of the models are weighted the same. So this is just the mean of the model ensemble means. And this is based on 6 models that you can see on the left-hand side. IPSL, MPI, CSM, MIROC, HADGEM, and NORCPM, which are the ones that we have, that data is available for initialized simulations in CMIP6 on ESGF. Now, the plot on the top left-hand side is also slightly different from the one that I showed before, in that this is not CMIP5 initialized hindcasts, but this is actually CMIP6 initialized hindcasts. So this multi-model mean SST hindcasts lead year 5 to 7 for CMIP6. Top right-hand corner, historical simulation CMIP5, same models, multi-model mean, and at the bottom, the difference. Now, if I add the historical simulation for CMIP, there we go. For CMIP6, this is how the historical simulation for CMIP6 looks. And I find that difference to CMIP5 quite striking. So much of this low skill in the subpolar gyre region that we had in CMIP5 seems to go away in CMIP6. Again, this is the same multi-model ensemble mean. Now, you might argue that probably this is just because we have 10 more years in CMIP6 than we do in CMIP5. But actually, and that is what you see in the middle at the bottom now. So this is the difference plot between initialized and non-initialized prediction skill in terms of correlation again for CMIP6, but for the CMIP5 period. And there's still a significant improvement from CMIP6 over CMIP5 in the historical simulation in the subpolar gyre region. From now on, I will be looking only at the subpolar gyre region, which is the one that's marked here in a black box, to look at this a little more closely. And before I go on, I want to make absolutely clear that this is only the case for correlation skill. So as soon as we look at root mean square errors, there is still a huge influence or a significant influence of initializing the model simulations to generate skill. So all of this, everything I'm saying is just for correlations and not for absolute magnitude. So this is now the average skill for the subpolar Gyre region. You can see it at the right-hand side. Thank you. For the CMIP 6 time period, and left of that for the CMIP 5 time period. The colors are black is initialized CMIP 6, red is non-initialized CMIP 6, this greenish color is initialized CMIP 5, and blue is non-initialized CMIP 5. Now another thing you can do is you can look at this skill in time slices of 30 years. So what I'm now going to show is essentially this this full skill, but broken up into 30-year time periods with a sliding 30-year window. And that's how this looks. And I think the most striking thing, and then I'm going to stop because I'm running out of time already. The most striking thing you can see here is that actually, although there is still a bit of a difference between initialized and non-initialized skill in the subpolar Gyre for the CMIP 6 period, for example, in the CMIP 6 model systems, actually there's virtually no difference between the two since about 1980. And yeah, I'm currently looking into why that is. I also have different regions that I look at. Here are time series. If anybody has a question, I can bring them up again. I'm trying to currently attribute this to forcing, because that's what this suggests, right? That this variability in the subpolar Gyre is actually forced and not only internally forced, or a product of internal climate variability. And I did that using DAR-MIP simulations, so detection attribution MIP simulations, and it looks like the first part of this high skill is forced by aerosols, stratospheric aerosols, and the latter part is actually arises from natural forcing, which in this case would mean volcanic eruptions. So everything essentially since the 1980s in the subpolar Gyre in CMIP 6, much of the variability seems to be actually forced from volcanic eruptions after Mount St. Helens and El Chichon in the early 1980s. These are apparently also followed by an increase in AMOC, and that then seems to give rise to SST predictability in the North Atlantic subpolar Gyre. Detailed analysis is ongoing. So this is what I showed you. What I'm doing right now is I'm trying to find out why exactly this is the case. The skill is so high in the historical simulations in CMIP 6. And I also look at the impact of ensemble size right now, because the ensembles in CMIP 6 are obviously much bigger than they were in CMIP 5, and this might have an impact. But first results suggest that this actually doesn't, it does make a bit of a difference, but it doesn't explain all of the different skill between CMIP 6 and CMIP 5 in historical simulations. Thank you.
Thanks, Leo. Thanks for a really interesting talk. Okay, we've got a couple of questions waiting, so I'm going to go for at least for one from Tim, and if we've got time, we'll go to answer. So, Tim?
Yeah, right. Hi, can you hear me?
Yes.
Great. So, would it be the right summary, a too short summary of your results, that it's this decrease of the benefit of initialization is not due to worse decadal predictions, but so much better historical runs?
Yes. This is an absolutely fair summary.
Okay, thanks. Interesting.
Okay, given that was a quick answer, Antje, do you want to ask your question?
Yeah, I'm just having a comment on your finding that the skill doesn't improve in the recent periods. Maybe that is due to the fact that you're using the anomaly correlation, which is already very, very high at the scales you're looking at. And perhaps if you would sort of detrend or so to look at the measure that is lower, that has a potential to increase, because with correlation you can't go higher than 1, so that might be a limitation in the method how you estimate the skill.
That is a very good point. We did look at the trended time series, which essentially lowers overall skill, but the conclusions stay very similar. So we still do not have much of a yeah, for a lack of a better term, I'm going to call it added value of initialization for correlation skill. Again, this is only for correlation skill. in the subpolar gyre also for detrended time series.
Okay.
With RMSE, this is a different story. Because, and now I am going to show the time series. If you just focus on the bottom right here, the thick black line is observation. This is, let's just look at the shift in the 90s. The thin black line is the initialized predictions, and the red line is the non-initialized predictions. And you can see that the sign of the change in the red line is right, but the amplitude is off. So there's still much more noise in the uninitialized model systems than there is in the initialized model systems, and that explains why there is more of or less of an increase in skill in correlations than there is in RMSE.